Today's lesson is going to be all about going to talk a little bit. Well, we're going to do some stuff with percentiles. That's the big thing in box plots today. But the whole purpose of this week in class and on the videos, and we're talking about coming up with different measurements for how to describe data. So, for instance, if you get a list of data, say 1,000 people. Anytime I see 1,000 numbers, the first thing that anybody does is oh my God, let's take the average of it. And that's the first thing you do. Why? Because you're trying to describe what the whole set looks like quickly. And one way to do that is to show where the middle is. Okay. And so this week there's going to be talk about mean, median, those two a lot. All right. And in class, we normally go over this a ton more. But trying to ways to describe the median the most. Obviously, sometimes we'll talk about the mode. Again, you learned all this stuff in third grade. Mode we don't really use in real statistics a ton, although it is interesting to note, what is the most common thing that happened. Like when I grade a test, I see people miss problem 2 a lot, let's say. I want to go find out why. Yeah, because it's the most commonly missed question, but why is it? Did I do a bad job of explaining it? Was there some reason why everyone's missing that question? I don't know. And so it is important. It's not unimportant, but it's not necessarily as big a deal as the median or the mean, which is the average, and the median, which is the middle number. I'm a big fan of like keeping up on what's going on in the world around me. When you listen to statistics come out from the government, you will see frequently they'll quote the median family income, median house price, median this, median that, and the reason for that is because if one person, I always like to use Bill Gates or somebody, moved to St. Helens, okay, and they would build a commensurate house with the amount of money they have, and it would be several multi-million-dollar house. If they put that in town, and you went out and took a sample of 150 homes in this town, and one of those happened to be Bill's, what you'd see is that the average house price in this county, in this city, would be something like $800,000 or something. Because even though the rest of these dumps don't cost a lot of them, and you'd get quite a few of them, that one house that's way over there at $7 million would drag the average toward it greatly. Okay. Something to think about. Baseball just started, and the Giants already suck. But anyway, that's another story. Sorry, I'll get off my soapbox. Every year at the start of the season, every year there'll be a great baseball player who starts out terrible for the first week or month, and they're like, that's it. He needs to hang it up. And like, what are you talking about? Dude's a career 300, 325 hitter. What are you talking about? And sure enough, here it is, mid-August. Where's he at? He's right back where he's supposed to be. Okay. And every spring, there's some guy that sucks, and he's like tearing it up for the first week and a half of the season. Oh my God, he's going to be the first 600 hitter. What are you talking about? And sure enough, at the end of the year, he's barely hitting 200. Okay. And why is that? Well, it's because he has a very small sample size. Look, he's 4 out of 6. Ooh, that's really good. Yeah, it's 4 out of 6. He's hot. Okay, it's called getting hot. And then over time, you're going to taper back down to what the long-term average is. Okay, every year I have a parent at school that come up to me and say, well, how come my kid's grade's bad? Well, he's missing, he's got bad grades on all these zillion assignments. Okay, well, what can he do to make it up? Well, he can turn some of these assignments, or he hasn't even turned anything in. So then the mom will get on him, and he'll turn in one assignment, and he'll do okay on it. And then the mom will say, well, how come his grade didn't go up? He's like, he's got 87 zeros, lady. 100% on one assignment is not going to bring that up. He's got instead of having a 0%, he's got a 3% in the class now. And well, I don't think average, that's literally how averages work. Okay. So did it pull it up a little bit? Sure. That 100 grade pulled it up a little bit. Obviously, the majority of them are down there at 0. And so I'm not going to go through how to find the median and mean. That's in videos. And let's be honest, you should know that. But think about that. That's the reason we talk about median is always quoted in big time things, because there's always somebody that's going to skew the data. Okay. I remember reading an article in the Oregonian some years ago. There was some awful house. It was the only awful house, I guess, in Lake Oswego. And it had been that way for years, and it had been rented for years. And the guy that lived there worked at McDonald's, and he rented it for probably an unsightly amount of money because it's Lake Oswego. Anyway, they were tearing the house down to make room to build a new house. And they were just upset. they're upset, you know, people were upset because he was going to lose his house and this and that. And I'm like, whatever. And so the idea, it was interesting though, is because they're talking about the average house price in Lake Oswego. Well, just like Bill Gates moving to St. Helens would drag the average up greatly, that one house, if it had been in a sample of say 100 houses in Lake Oswego, would have drugged the average house price down in Lake Oswego. And so if you look at the median, it's just one more term. And so that's kind of a big deal. Again, that'll be in the videos this week. But the idea is to try to just look at all the data and try to summarize it with one number. And that's kind of the whole point of that. Another thing you're going to talk about in the videos this week is standard deviation. And it's an idea of how spread out the data is. Okay. So how weird the data is, perhaps, if you will. Spread out, what we mean by that is how spread out around the mean it is, or how spread out around the average it is. And so there'll be times when, like for instance, I used to teach with this one guy. His tests were so easy, and the kids, like, he'd always come in, James, every kid had the average in my test was an 83%. I'm like, that's great, Bob. And so, but his tests were so easy. And he goes, what was the average on yours? I'm like, 74 or 78 or whatever. He's like, oh, that's great. And he'd always like, he thought he was so good. And I'm like, yeah, the difference is, Bob, you have I had these huge class sizes. Why are you in my class? I can't stand Bob. I can't stand the other guy. I'm like, oh, okay, great. I would always end up with the kids who didn't want to do anything. They would get 0%. That's no joke. Or like 10%. There's terrible grades. And they didn't do any homework. They failed the test, whatever. I'd also get kids that get 100 and some percent because they'd answer every single extra credit problem correct. And then I get a bunch of kids in the middle as well. His kids were really tightly packed around the average. If you looked at his standard deviation, the idea is everything was right around 82. There was hardly any A's, there was hardly any C's. They were all just packed right, and no F's. They were all packed right tightly around 82. My class was spread out all over the map. You would have kids that didn't get anything. You have kids way up here. It would be completely spread out. And the standard deviation is just a way of trying to quantify that as a number. Okay. Something to think about standard deviations, however, is the fact that it's relative to the size of the numbers you're dealing with. Okay. So when you're looking at people's heights, a standard deviation of heights in America is about 2 inches, or inch and a half, 2 inches. That is, we're pretty tightly packed around the average. You don't see a lot of extremes height-wise in America. You don't, or anywhere for that matter. You just don't. They're pretty tightly packed around the average. When it comes to house prices, because the average house price in, let's say in Portland, might be $300,000, the standard deviation, because that's such a large number, the standard deviation is going to be a big number. It might be something like $50,000 or $70,000. It's relative to the size of the number. Obviously, you can't have an average height in America of men to be 70 inches and then have a standard deviation of 50,000. It doesn't make sense. Obviously, 70 is a fairly small number. You're going to have a fairly small standard deviation. Okay. Again, the idea of it is it's relative to the data set. So I can't say, hey, look, a standard deviation of 5 is big and a standard deviation of 2 is small. There's no such thing. It's relative to the data set. So if you had people, if our average height was 70 inches for men in America, and you had a standard deviation of 5, it would be nothing to see people who are 8 feet tall. We would see it all the time. It would be weird, but it'd be weird. Like my son is 6'6", and he kind of stands out for being tall. 8 feet would be like the new 6'6". Okay, it would just be, that's not unwieldy big at all, because we have such a large standard deviation. Ditto on the other end, you'd see a guy who was like 3'7" all the time. It would be not weird at all to see that, because that would be such a huge standard deviation. And now, like, ever see anybody, like, you see a 7-footer, you what? And you try not to stare at him. Okay, it's okay. It's weird. It stands out from a crowd, of course, but it's not unheard of. But who ever been 8 feet tall? I think the tallest guy isn't even 8 feet tall. But anyways. It would be completely, it would see it every day if we had a standard deviation of 5 inches. It wouldn't be strange at all. Okay. And so 2 and 5, 2 is small when it comes, or small-ish when it comes to height. 5 is big when it comes to height. 2 and 5 are both ridiculously small when it comes to house prices. So you'd have to be huge numbers. Okay. But again, it's all relative to where you're at. Okay. So that's kind of the game with those things. Today, what I want to talk mostly about, well, it's a couple things I want to talk mostly about. I'm going to go to this screen here. Excuse me. Maybe. There it goes. There you go. As much as I would like to do some tank problems, we're not going to do that. We're going to do this. There we go. You've all seen the idea of a bell curve, right? And you all talked about it and everything. This is called the normal distribution. And, well, I shouldn't say that. It is a symmetric distribution, but usually the one we see is a normal distribution, okay? And we're not going to talk a ton about it other than to say, listen, a lot of things in our daily life are normal distributions, where the average is right here in the middle, the average, or the mean, if you prefer, it's right in the middle. And then we are going to go out by standard deviations. So this is one standard deviation above the mean. The mean. And this is one standard deviation below the mean. And I'm not going to hold you to this because it's not part of the class, but I like to go ahead and just put it out there. For American men, it's roughly 70 inches is our mean, our average of the United States of America. And the standard deviation is about 2 inches. So that would mean something like this, okay? But it's true for any population. If you go within one standard deviation above or below the mean, 68% of the individuals will be within one standard deviation of the mean. What does that mean to me? That means to me, if I see a dude who's 5'9", I don't even make a note of it. I'm like, all right, cool. If I see a dude who's 5'11", I go, I don't even think about it. It doesn't even register in my mind because it is very, very common. 68% of the data of the population will be in there. These are very commonly cited things. If you go out 2 standard deviations, that would be, this is 2 inches, 2 more inches would put me at 74 inches, which is 6'2". And down here, 2 more inches puts you at 5'6". Okay. Within 2 standard deviations of the mean, that's 95% of the population. Now think about that. When you do this, do you rarely, I mean, how percentage-wise, the people you walk past on the street, what percent of them are taller than 6'2"? Boy, not many of them. And what percent are shorter than 5'6"? Not many of them, that's right. And it's strange because, again, everything is in that middle groove. And then, turns out, oh, this stupid computer is not going to work today. Great. Turns out if you go out another standard deviation, which is 6'4" on the top end and 5'4" on the bottom end. Oops, 64, you dummy, which is 5'4". That is 99.7% of the population lie between those 2 values, okay? That is why when you say, Jay, you're pretty tall at 6'3", I would say, yeah, I'm fairly tall, you're right. However, that's all relative to the company that I keep. Okay, so my 2 boys are taller than I am. Matter of fact, I feel rather short around them, 166 and 164. Well, he's almost 6'5", I think. The people that I work, there's people that I work with. There's several people that I work with that are quite a bit taller than I am. There's some other people that I hang out with that are taller than me. I don't feel abnormally tall. However, sometimes when I get around different groups of people, I'm like, all of a sudden I stand out like a sore thumb. Okay. So the reason I draw this picture is, for one thing, when you go to 243, you will see this picture a ton and you'll deal with it a ton, and the normal distribution, okay? So I like to introduce it. Whoever unmuted themselves, can you mute yourself again? There you go. I like to introduce it just from the standpoint, I think it's good to know and to have seen it in your life before you get to stats 243. And you'll see it a bunch then, and you'll fool with it a lot then. Darn computer, quit doing that. So I like to introduce it. But the main reason I like to talk about it is because it's all relative, okay? And most things we do in our life are relative, okay? We're always going to be comparing ourselves to something, okay? And so usually we compare ourselves to other people. Sometimes we compare ourselves to quote unquote standards. That's true. And some of us do it to both. I mean, for instance, yeah, I did my job. I met the standard. That's great. And then I look around to some of the people that I work with and go, how do they still have a job? But anyway, whatever, that's another story, I guess. But we look at these things and you realize that we move in and out of groups all over our daily life, where sometimes I'm with this group, you know, I feel smart. And sometimes I'm with this group, I feel really dumb. Okay. Sometimes I feel tall. Sometimes I feel short. And why is that? It's because I move back and forth between different groups. All right. And so, true story, when I was in high school, I was getting letters to go play college football. And I lived out in the sticks, and I didn't even want to go to college, except when they said you can play football. I'm like, oh, well, maybe I will go play. That'd be fun. I never, ever thought to myself, I want to go to college. It was always, oh, I want to play football. And so when I got these letters, it was pretty exciting. So one time I got a letter from Princeton. And so I filled everything out, and they wanted to know, you know, your height, weights, where you live, your speed, and all this stuff. And I think my coach sent in some tapes and stuff, and they were pretty impressed. And then my SAT scores came back. They're like, yeah, we're not interested anymore. And it kind of hurt my feelers a little bit, but I didn't know what an SAT was till I went and took the thing. Other schools, when they saw my SAT scores, they're like, wow, that's a really good score. There's this long pause for a football player. And so if you think about it, here are football players, and they're at, oops, that's a terrible graph, sorry. These are for all football players. If you just weed out the football players, the average score might have been a, 920 or something horrible. So that when Jay scored over here, oh heck, I'll say it, I'm too old, I don't care anymore. 1120. Kids in my high school that I teach at now, they'll come in crying about their SAT scores, and then they'll tell me it, and I'm like, really? Because I got 1120, and they're like, wow, that's not very good because they know I teach math or whatever. I'm like, okay, well, it was a long time ago, number one. I never studied for it, number two. I didn't know what it was about, number three, and whatever. And by the way, I played football, all right? And it was this idea that, and by the way, I did better on the verbal than I did on the math. Anyway, there's the idea that when you compare it to other football players, it was terrible. When you compared it to, and by the way, this is who I compared myself to, people who have college degrees, let's say people who studied math, whatever, in college, like got a degree in math, the average might have been a 1400, which is why I felt really stupid around them, because mine was terrible, all right? And so I operated in these two different setups to where in some groups you look like a freaking genius, in other groups you look like a moron, and you're like, somewhere in the middle is where you actually are. But that's just how we always do things. You just make a mental note of it in your head. You're like, wow, in this group of people, maybe I feel smarter than average, right? Other groups of people, you're like, geez, I feel really short in this group of people, or really tall, whatever it is. Your mind does it automatically. What you're doing is you're comparing yourself to what you see as the average and so on. Now, we will use this a ton in statistics to do comparisons when it comes to, how are my products doing, okay? So if you are manufacturing a product, you don't want really any slop at all. So when the machine, you're testing it all day long, testing. Let's say you're making Ritz crackers or whatever. If they start coming out the size of like sand dollars, you should probably shut the machine down. All right, that's not okay. They're supposed to be, Ritz crackers. And so you're testing them all the time for quality, taste-wise, for size, for whatever. What you would like to do is you'd like to be able to catch them before they get so big that they're sand dollars. And so you'll test them and you'll say, geez, there's always going to be slop. But if I take this average and compare it to what it's supposed to be, this average of a sample, and I compare it to what it's supposed to be, I can show using this, using this picture of using this normal distribution and saying, listen, here's what it's supposed to be. The average is supposed to be, I don't know, an inch in diameter or whatever they're supposed to be. And I take a sample, and there's some cutoff value over here. If they are smaller than 0.95 inches or something, and if they're bigger than 1.05 inches or whatever, if that average is bigger than that, hey, shut the machine down, okay? People will go on Yelp and complain about our Ritz crackers, and we'll lose market share or whatever, right? This is how this stuff is done all the time, okay? In the real world, I said in the real world, in other places, like for instance in education, which is not the real world, we will do things like we will change teaching strategies. We'll do different things, and we'll compare, and we'll see how did this one do versus this one. It's used in drug trials. This group of people got this drug, this people got a placebo, or they got a different drug. And we can compare them to see if there's a statistical difference. The idea is that if you are out here beyond some cutoff value, which we're not going to get into this class, how we come up with these cutoff values. If you're out here or out here, there is almost no way that happened randomly. In other words, it's not like you just took a random bunch of samples from this group of population that was getting some drug for whatever, I don't know, warts or something. And this group over here was getting a different drug for their wart problem. And this one, these people, their warts completely went away and whatever. And these people didn't. And you take the average or whatever of that and you compare them, you're like, geez, the probability that I saw that happen is like 0.00002 if there's no difference. And so what did we say? Well, look, I don't believe that there's no difference. I think there's a reason, because this medicine is better than this medicine. And it comes down to two things. It comes down to what we talk about, and we've talked about this a little bit in the data. We said, are they independent or not? Okay, remember that? We talked about that. We're looking at the data. Are these two things independent? Well, we're looking at ratios or probabilities or proportions. And it's based on the probability situation. There's almost no chance that this happened randomly, that I selected people over here whose warts just magically disappeared versus people in this group over here, which they didn't disappear. No, in fact, the reason that these people's warts went away is because this new drug works better than this group over here, than this medicine over here. That's how it's all based on. Okay, and so I bring it up to show you that this is kind of what it's going to all be about, but it's going to be based on the average here, the mean, and the standard deviation is how spread out the data is. Okay, when you buy a Ritz cracker, are they all exactly the same diameter? No. Would you actually have to get a tape measure out to see the difference? Yes. Why? Because they don't make, like, they don't go from this big to 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 this big. Ritz Cracker Company, Nabisco or whatever, they have tight tolerances, as does everybody else. It isn't Saturday Market, right? You go to Saturday Market and you buy some kombucha or something from some guy, and you go next week and you're like, ugh. And they're like, yeah, like, I don't know, I didn't clean out my bathtub very good this week or something when I made this batch. I mean, there's slop, there's everything, but you write that off as it's artisanal, so it's fine, and you still pay for it. When you go to buy your Ritz crackers, you want your dadgum Ritz crackers to be this big, and they better taste the same every time. And it doesn't matter if you buy them in Maine or you buy them here in Oregon, they better taste the same, they better look the same, they better be everything the same. That's how manufacturing processes work. When you buy a Budweiser, I mean, I say that one, whether you like it or not, it is one of the biggest beers. It doesn't matter where you buy a Budweiser, when you crack it open, it will taste exactly the same no matter where you go. And that's the whole point of it. When you go on vacation, a few people are gutsy enough, I'm not one of them, to go eat at some small little establishment, hole in the wall place in some random town. Now, a diner I will, but like some other places, not so much. Why? Because you don't want to ruin your vacation having intestinal issues or whatever, you know, because maybe you get food poisoning in some little place that looks kind of sketchy. In my old hometown, there was this one little taco place that I had driven by it a million times. It was right after we first got married. My wife, she worked in town, and she ate there once, and she pointed out to me, and I'd never even seen it before. I'm like, you ate there? So we went there, and it was good, and we started eating there a lot. And it was great. I would never in a million years eat at that place just driving through town. Number one, I probably wouldn't see it. Number two, if you did see it, you're like, I don't think I'm going to go there. When you get off when you're out driving around on vacation, you eat at places that you know, whether it's like Wendy's. I'll eat at a Wendy's sometimes on a vacation because I can't find anywhere else that I know. It's not my favorite place to eat, but I'll eat there if I'm on vacation because I know it. I know that I'm not going to get sick eating this stuff. Like Applebee's is not somewhere I normally go. If you're on vacation, like, oh, geez, well, I guess there's an Applebee's. It's that or Denny's. I guess I'll do Applebee's. It's not my favorite. It's not the greatest food or whatever, but it's a known quantity. Okay, and that's what statistics really comes down to. Oftentimes, it comes down to we do this all the time with ourselves. We know that if I went to that little taco stand, it could be a really big hit over here, maybe a really big miss intestinally speaking for me. And so maybe I don't go there. Maybe I take that average look in the middle right there. How spread out is the data? That's what it's all about. So standard deviations and averages, if you're going to take statistics coming up soon, that's going to be a big deal. So the purpose of this class is just to introduce them. That is all. Okay. So again, this is what we call, typically it's the normal distribution, but really it's symmetric distribution. So a normal distribution is a specific kind of symmetric distribution. There are other symmetric distributions. The normal is the most important. It's the most common. It's the one that everyone spends the most time talking about. But there are others, but they are symmetric. And what that means is that the mean, again, or the average, whatever you want to call it, I don't care, and the median, and for that matter, the mode, are all right smack dab in the middle. This is really a picture of, if you will, you can visualize it, what the histogram would look like if you were to draw a histogram. They would have the exact same number, or pretty darn close to it, on both sides. It would be nice and symmetric like this, okay? You will, darn it, stupid computer, I don't know what your problem is. You will see ones that are like this. We say this one is skewed to the right. Some books will call it positively skewed. I don't really care for that one that much. This is the idea that the average, so if you look at this one here, here's where the mode is. The most people are right here. Right? If you were to draw that bar, I mean, there's this really tall bar right there, and then it kind of peters off coming this way. This is, if you will, Bill Gates moving to St. Helens. Right? So, you know, what does the average price of houses look like now? Well, all of a sudden, here's his mansion out here somewhere. Here's all the rest of the shanties in town, all right? And so if you think about it, here's the median is going to be pulled this way just a little ways, and the mode, and I'm over-exaggerating it here, and that the mean is going to be pulled over this way. The average is always greatly affected by these extreme values, always, okay? And the opposite of that one, oh, I hate this. Why are you doing that? The opposite of that one is this one. This is skewed to the left. Could be written as negatively skewed as well, if you like. And this would be the idea of, here's the mode. The most of them occur right here. The median is still here. And then the mean is, again, exaggerate a little bit, but the mean is brought over this direction. And it's been influenced by these weirdos, this weirdo probably up here. Why do I say weirdo? Because there's not a tall bar. If there was a bunch of them, then it would be a bigger bar up here, and all of a sudden it wouldn't look that weird anymore, okay? And so this one is, we say again, skewed to the left. This would be the, I don't know, the the bad house in, the one bad house in Lake Oswego. If you want to like put a, if you want to put a picture to it, I guess, all right? What does that do? It pulls the average down towards it a ways. Again, I've exaggerated it a little bit, okay? But that's in the order they'll go in. I like this one because mean, median, mode, in this order, boom, 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 they're alphabetized. That's how I remember it, okay? When I was a kid, that's how I had to remember it. So we'll see that. And so what ends up happening is when you have a situation, darn it, why are you doing that? When you have a skewed data, like either this group or this group here, instead of using the mean, you should use the median to describe the center. And that is when you look at the average income in the US, okay? Well, if you figure in LeBron's income in, okay? Whoa, he makes a lot. He does. Yeah, there are other people up there that make a lot. There are a lot more. And when I say a lot more, I mean a lot more of people that make nowhere near that, okay? So percentage-wise of the population, pro athletes is diddly squat when it comes to percentages, okay? And so when you look at stuff like that and you figure it out, you're like, what are they doing? Well, they're pulling the average toward them, and they're skewing the average. The average income in the US might be, I don't know, whatever it is, I have to go look it up. I'm not familiar with that because it's the median that makes sense to us. I care about the median. Those people out there on the far end, whoever makes the most money on the far end income-wise, is balanced on this end by people who make diddly squat on the other end because they're just one person. And the median is a special property. And the median we will also refer to as the 50th percentile, okay? 50% of the population make less than you, if that's the case. If you are at the median, 50% of the population is shorter than you, whatever it is, okay? And 50% of the population has a less IQ than you if you are at the median, okay? That's what that's saying to us. Now, the reason I bring this up is because it's all, with the rest of the whole class, and the biggest part of this is to set up where we're going with the median, well, the percentiles rather. So when I look at this here, the percentiles, that's the 50th percentile. Percentile, percentile is the percent of the population less than you. So if you scored the 95th percentile on a reading test, you're pretty good, man. 95% of the population did worse than you, so good for you. If you scored a 62 percentile, 62nd percentile on a math test, well, you're above average, but you're not rocking it. If you are in the 30th percentile when it comes to, I don't know, some kind of comprehension test, yeah, it's not too good. All right. Now, again, comprehension test. And so the idea is it's just a way to compare yourself. Where do you fall? And so obviously in education, we look at it for like, oh, okay, well, this kid struggles in, reading comprehension. We're going to do some work to try to catch him up. Obviously, when it comes to income, that you can do things with politics in that regard. People in that obviously care about it. Doctors in particular care about percentiles, what percentile you are, because they track you with this thing. Okay. And so if you have kids, you remember taking the kids to the doctor back in the day, and you saw a chart that looked like this. Something like this. I'll show you an exact one here in a minute. And the idea is what they're doing, the doctor will track your height over time and your weight and so forth. So you come in, you bring your baby in, they ask you, they clearly can see how tall you are. You, ma'am, are 5'11". That's cool. How tall is the dad? Oh, he's 6'7". Oh, sweet, cool. That is why your baby is tracking up here, like toward the 95th percentile, perhaps, when he's like 6 months old. And then they track him, and then your baby starts doing this at 1 year, at 2 years. Wait, Jay, he fell below the average. This is, or rather, the median. That's right. He fell below the 50th percentile. Is that weird? Yeah, that's odd. Okay, the dad is 6'7", the mom is 5'11". That's strange. Watch this child tracking. What happens to the doctor? The doctor goes, we need to check out what's wrong with your child. No, I don't mean to offend you or scare you or anything, but you guys are off the charts height-wise. Your child is tracking at about the 10th or 20th percentile height-wise. There might be a problem here. Okay. Likewise, if we had some people here in town that we used to know them, and their one daughter, they discovered a problem with her disease because she was tracking off the charts on the upper end of things. Okay. I think she's 6'5" now, 6'6", but they figured out that she had a problem based on how high she was, fast she was growing, because the dad's like 5'9", the mom's like 5'7" or something. And the daughter was just tracking like this her whole life. And so around age, whatever, they found the disease and they were able to do some work to her, but it's one thing they can't really cure, but they could treat it a little bit or whatever. And it's the idea they track it over time to see what's going on. Now, there'll be times when a person obviously will track low and then all of a sudden they just jump up in 1 year and grow like a weed, of course. But percentiles is what it's all about. Genetically speaking, if parents that are this big should have fairly tall kids, all right? Likewise, if you're fairly short, or maybe the husband's tall, the wife's short, okay, the kid's going to track differently, whatever. But clearly, this is a situation where they'll track that over time and see what's happening. I used to make my high school kids do this. I gave them a chart, a growth chart for men or for boys and girls, whatever. I said, go home and see where your mom marked on the door how tall you were, or grandma, or find somebody, right? So this one kid comes back. He's like, I never knew I was so tall. And he's like 5'6" or 7 or whatever. I'm like, dude, you're not tall. Let me see this. Or 5'8", I think he is. And so I'm looking, I'm like, dude, you graphed your data on the girls chart. He's like, oh, that makes so much more sense now. I'm like, yeah, brother, dude, come on. But clearly it matters that, you pay attention to which one's which. Okay. So the question is, how do we find percentiles? Okay. From a set of numbers. All right. Well, let's look at that. So if you had a data set, and I'm just going to use nice, easy ones, if you don't mind. I don't have to do any math. It's kind of early to do math today. Okay, here I list them in order, just like Mrs. So-and-so told us how to do this. This guy here in the middle is the median, yes? So you put them in order. There's 7 of them. The middle one is the median. No, that was easy. Cool. Oh, wait. Second problem Mrs. So-and-so gave us to do. Oh, no, there's 8 of them. What did she say to do on this one? You may recall or you may not. She said if there's an even number of them, you average the middle two. So the average of 30 and 40 is 35, right? Remember that? That's not new or different. We're going to use that same basic procedure in a minute to come up with the formula of finding percentiles, okay? Now, I will say this, just like with a lemon meringue pie recipe, there are multiple recipes to do a lemon meringue pie. When you're done, you get a lemon meringue pie, okay? There are several different algorithms or recipes for finding median. I'm going to teach you the easiest one because I'm really more interested in that you understand what it means than I am understanding, when I said median, I meant percentile. I want you to understand what it means. If you're doing giant reams of data, you're gonna have Excel do it for you. And in Excel, they use a different algorithm, which is great. It's a different algorithm. It's one that the computer can do and do a nice job of. But in terms of what are you getting? You're getting a percentile, okay? And it's gonna be basically the same number that you get doing it my way, or this lower way of doing it, which your book teaches. So here's how it goes. We're gonna number the numbers. This is the first term, second term, third term, fourth term, fifth term, sixth term, seventh term. And so if a person was doing this, you're like, geez, I need the 50th percentile. So I'm going to take 0.5 for 50 times the number of terms, cool, is equal to the 3.5 term. And you're like, Jay, there is no 3.5 term. And I know Mrs. Smith or whatever told me that 30, which is the 4th term, is the median. Oh, well, how would you get from 3.5 to 4? Well, you would round up. So you'd round up to the 4th term. And so that's a pretty cool thing. You would take 0.5, which is the percentile, times the number of terms, and you would then round the answer up. To find the term that you want. Okay, so again, I want the 50th percentile, which is the median. So 0.5 times 7, because there's 7 terms, comes out 3.5. Sweet. I don't want the 3.5 term. There is no such animal. So I'm going to round it up to the 4th term. That's it. Nothing to it. Who's the 4th term? 30 is the 4th term. Okay. Now, likewise, on the second one down, it was 8 terms. Uh-oh, that's going to work out differently. 0.5 times 8 is 4. Oh, great. I didn't have to round because it's the 4th term. It's a whole number. Not so fast. Mrs. So-and-so said that when there was an even number of them, you average the middle two, which is the 4th term in this case, and the 5th term. So what the big kids say when this happens, so if the answer is a whole number, you average that term and the next one. Okay, and the next one. So not terribly difficult. So you're like, Jay, what if I wanted to find the 25th percentile for the second one? Let's find out. I don't know. Cool. What is the 25th percentile times 8? Well, 25% of 8 is 2. Oh, dude, it came out even again. It did. So come up here. So I want the second term and the third term, and I'm going to average those two. And what is the average of 20 and 20? Well, the average of 20 and 20 just happens to be 20 again. So that would be the 25th percentile. And we could do that for any number of terms. It's really straightforward to do, okay? Now, let's do this set of data here. Again, I'm gonna come up with some easy ones because I don't wanna have to do any real math. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. Yeah, I don't care, whatever. Now let's do 11 of them. Cool. So if I wanted the 70th percentile, okay, first of all, can we agree that it's none of these guys down here? Can we all agree it's none of those? Because you need to have 70% of the data less than you. So it can't be any of these guys. I mean, clearly there's only like 2 numbers less than me when I'm down here. So it can't be, that cannot be the 70th percentile. So we're looking over here somewhere. I don't know where, but somewhere over in here, okay? So when I look at that, I think to myself, all right, cool, there are. So I'm at 0.7 times 11 comes out to the 7.7th term, which doesn't make any sense. So I'll round that up to the 8th term. Awesome. 1, 2, 3, 4, 5, 6, 7, 8 term. This guy right here, which is sad. I didn't mean to do this on purpose. I didn't do this on purpose. It's the 70th percentile. Okay, not because he's 70, just because of where he's located in the data set. Okay, if you wanted the 20th percentile, that comes out to be the 2.2th term, which will round up to the 3rd term. 1, 2, 3. This guy right here happens to be the 20th percentile. Okay. Interesting to note that somebody might say to you, hey, Jay, what's the 22nd percentile? I don't know. Let's find out. Crap, I have to use a calculator. Oh, it's the 2.42th term, which again doesn't make sense, which means, again, we'll round up to the 3rd term, which means this guy is the 20th percentile. He's the 22nd. He's several other percentiles in that neighborhood. In other words, he wears several hats in that neighborhood. So just be aware of that. That will happen. In a small data set, just like everywhere else, in a small company, what do? I do about 15 jobs. That's right. So the number 30 in this case might be everywhere from the 18th percentile to the 24th percentile or something. In other words, he might fit every single one of those guys. Don't worry about it. Just know that that could happen. Okay. Another data set here. Oops, not 45. What are you doing? 1, 2, 3, 4, 5, 6, 7, 8. Yes, one of these things is not like the other. That is a weirdo. Can we all agree? That's a strange one. But where would the median be? Well, the median, of course, is the 50th percentile. 1, 2, 3, 4, 5, 6, 7, 8. So 0.5 times 8 is 4. So I'm going to take the 4th term and the 5th term and average them. 1, 2, 3, 4, 5. The median is 30. Okay, that's the median. All right, it's 30. The average is going to be huge. I will go ahead and compute this one just for fun. So 10, oh shoot. 10 plus 20 plus 60 plus 40 plus 50 plus 190 divided by 8 is, oh, you idiot, 20, what? Oh, I'm sorry, it's 370, you moron. 370 divided by 8 is 46 and a quarter. Can you all see it's 23 and an eighth up there? You see that? Obviously, that can't be the right answer, obviously, because where's the median is here. The average is going to lay over in here somewhere. Okay, it has to be, because this guy is going to pull the average towards him. And what is the average? The average is 46, and the average is up in here somewhere, 46 and 3/4 or whatever it was. Okay, why? Because of this goofy thing here. Now, that's quite a bit different. All right, but remember, the average is where the thing would bounce. Again, I'll cover that in the videos this week. You'll see that. All I'm interested in this week is what are the percentiles. So we'll find percentiles. We'll find them until we're blue in the face of finding percentiles. Okay. Now, the other reason I like to teach percentiles is because ever since you were in high school, if you're young, if you're old like me, you didn't learn these in high school. You learned them in college. But if you're younger, say in the last 20 years you were in high school, you learned box plots. This is how it went. Your geometry teacher said, hey, we're going to do box plots today. What does that do with geometry? Nothing. The state test is coming up and it's on the state test. Oh, well, that's cool. Exciting. Yeah, exciting. It's great. back in the day, they were kind of useful. That was back in the day before Excel, and you could make a histogram just like that, all right? Nowadays that we can use a histogram, we don't do this as much. Back in the old days, it was an idea of talking about, hey, what does the shape of this graph look like? If I were to make a histogram, what would it kind of look like? And so the idea is, it is something like this. Quit doing that. Okay, cool. Okay. Notice that my data is spread out, but my data is not that awfully weird. In other words, relative to each other, I mean, the 30 is close to the 40 is close to the 50. These guys are all close to one another down here. And the 150 is not out by itself because it's got a 140 and a 120. This isn't that odd. If there was a 300 on the end of this, that's weird. That's strange. It sticks out like a sore thumb, okay? But this isn't that awfully weird to me. So what we're gonna do on these box plots, we will always find the following things. We'll find the median, we'll find the 25th percentile, and we'll find the 75th percentile. And what we're going to be doing is we're going to be breaking the data into quarters. That's all we're going to be doing. We're going to be breaking it into quarters. The lowest 25th percentile, the next 25th, the next, and the upper 25th percentile. That's all we're going to be doing. And we're going to be delineating it with, in essence, a box. Okay, so it's pretty easy to do. This is how we do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 0.5 times 12 is 6. Great. Meaning I'm going to take the 6th term and the 7th term and average them. 1, 2, 3, 4, 5, 6, and 7. Here is your median. It is 90 rather. Okay. I'm going to get the 25th percentile. Sweet. 25% of 12 is 3, or the 3rd term. Again, because it came out evenly, I'm going to take the 3rd term and the 4th term and average them. So 55. That's my 25th percentile right there. Now, if you were a betting man or lady, you'd go, geez, 25th percentile, 1, 2, 3, like that. Interesting. I bet the 75th will be right in here. And you would be right, ma'am, sir. That's correct. 115 is right. Now, you can prove it to yourself if you want. Go right ahead. It's not going to hurt my feelings any. But I always use symmetry on this guy. It's the 9th term. So I'll take the 9th term and the 10th term and average them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and average those two terms. Okay. Now, as far as this box plot shenanigans go, what I'm going to do is I'm just going to draw myself a number line. 30 on this end. I'm just going to count by 10, see if I can pull this off, make it look good. Cool. So 90 is my median. So I'm going to draw a line right there. That's cool. 55 is my 25th percentile. Cool. I'm going to draw a line right there. 115 is my 75th percentile. Cool. Watch me do this. Dude, check it. It's a box. Nice. That's it. This is right here, the middle 50% of your data. That's what that means, right? Everything in the box is the middle 50% of your data, okay? Everywhere from the 25th percentile to the 75th percentile is the middle 50% of your data, okay? By the way, I will say this here right now. The 25th percentile is what I always refer to it as. Books always refer to it as the first quartile and the 3rd quartile. Of course, the 2nd quartile is the 50th percentile, which is the median. 2 quarters is 50 cents. Think of it that way. I don't really like thinking of it that way. I have no problem, but it's just to me, I prefer to think of it as percentiles. Why teach people 87 different things? Hey, listen, here's percentiles. Hey, here's quartiles. Dude, they're the same. Just understand what you're talking about. Okay. So when we're looking at this, all right, that's interesting. Well, now what do I do? What about the rest of the data? That's cool. But the only reason I still teach box plots, besides I have to, is because it's going to give me a way to identify outliers. All right, that's the only reason I really teach them anymore, besides, again, from the fact that it's in the curriculum, so I have to go over them. But the only thing that I think that they're really particularly good for is it's a way to quantify them, okay? So an outlier is a statistical freak show, if you will. Statistically speaking, it doesn't belong, okay? Now, whether that's you're at the college bar, everyone's in their 20s, low 20s for that matter, and you see some dude over there who's 53 at a college bar. Dude, what are you doing here? That's weird, okay? Get away, run along. Or likewise, like, you know, you're some 20-something-year-old guy and you pop up in the like, I don't know, you're wearing a suit and tie and you go to a Hell's Angels bar. What are you doing? Run away, don't be here, okay? That's just odd. It's strange, okay? You are super short, you're hanging out with NBA guys. It just looks weird. So height-wise, you're a statistical freak show, okay? When I taught math, for a long time, I was the only guy I knew who majored in math who played college football. Then I met another guy. He did not dispel the myths of college football people being weird. So, but there's two of us now that I know of, okay? It's weird. We are weird in that regard, okay? What this does is it allows us to, again, to put a quantity on, and that's weird or that's too weird, okay? The way I like to envision this is this. The more spread out my data is, I have to be really weird to appear out of the ordinary. When you go to Portland, if you're trying to stand out by how you are dressed or what you look like, you have to really, really, really try hard to do that in Portland, okay? Because you could do anything in Portland and no one's gonna even blink an eye. No one's gonna even notice you. Like, oh, I'm dressed weird. Yeah, but you gotta go way weirder than that to stand out in Portland. Versus if you go out in the middle of, I don't know, Nebraska somewhere, some small little town, and you know, pretty much, I don't know, whatever, here a bunch of guys, just, you know, country people, whatever, and then you show up and you don't even look that weird. And in Portland, let's say, you show up there, you're like, whoa, what is that? You're completely off the mark, and you didn't have to stand out. You don't have to stand out that far because everybody in that town perhaps dresses very similar to one another. So you don't have to be very far out to look crazy. Okay, maybe you left your cowboy hat at home, and all of a sudden, whoa, man, what's the deal? You turning a city guy on us or something? I don't know. So you don't have to get very far out to look weird in that case because everything's tighter together. So how we're going to do this is this. We're going to take 1.5 times the width of the box. This is how I like to say it, okay? Now, the book will always write it like this. They'll write it 1.5 times Q3 minus Q1. It's not wrong. And they'll call it the interquartile range, but that freaks people out. So what I like to do is 1.5 times the width of my box. So my box is how wide? Well, it goes from 115 on the top end to 55 on the bottom end. So that's 90. No, it's not. It's 60, you dummy. And 1.5 times 60 is 90. That's where the 90 came from right there. Okay. Now, what does this 90 mean for me? Well, 90 is, I'm going to come out here. I'm going to use a different color pen. And I'm going to come out here somewhere. I'm going to add 90 to the top of the box. So remember, the top of the box was here at 115. I'm going to go out 90. That's going to put me over here at 205. 205 is where the freaks begin. I don't know why I use that pink pen. It looks stupid. That's where the weirdos begin. That's the welcome to Freakville sign, if you will. It is the anything beyond here. I'm sorry, we got to draw a line somewhere and say that that's a statistical freak show. If there's anybody over there. On the low end of things, that is, we were at 55. If we come over here 90, that puts us at negative 35, I think. If anybody is beyond negative 35, they're an outlier, we would say. Okay, so go back and look at your data. My lowest data point is a 30. That's not an outlier. For it to be an outlier, it would have to be less than negative 35. So I'm just going to come over here to 30. And I'm going to make a dot and connect it on the lower end of things. On the upper end of things, our biggest data point was 150, I believe. And 150 is nowhere near 205. So once again, we'll draw a line and we'll connect it. And that right there is your box and whisker plot. And notice on this box and whisker plot, everybody's connected. That means there is no outliers. Well, we're going to do one here in a second where we have an outlier, and we'll demonstrate how that works. When you look at this data set, it's nice and spread out, but notice that this is 25% of the data. 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 They are basically the same width all the way across, yes? And because they're basically the same width all the way across, what would that look like? If you made a histogram of this, it would look something like this. It'd be fairly symmetric because these widths are all roughly the same. Okay, it would be kind of symmetric. We will do some other examples of this in a second, but we'll see some that'll look like this, where the median is really close to the low end. There's a little short tail on this end, there's a long tail on this end. And if you looked at the graph of this, it would tend to look like this, kind of skew to the right action. Because right here, that's 50% of your data, all piled in a really tight pile right there. This is also 50% of your data, but look how strung out it is. It is strung out over a long area. In other words, that one would be skewed to the right. And of course, you flip-flop it around and skew to the left. The idea of this was with five numbers, that is the lowest term, Q1, which is the 25th percentile, the median, the 75th percentile, or Q3, your book calls it, and the maximum number. With those five numbers, they call that the five-number summary, and you could then demonstrate what the graph would look like or what the population would look like simply from five numbers, which was a lot better than trying to do a graph from like 10,000 data points. Now, with 10,000 data points, I could have that in Excel just like this. I can have a histogram of it. But again, this was back in the old days. So again, the reason I teach them now still is mainly so I can identify what are outliers, graphically speaking. Okay. So I apologize. I am not feeling the net need to get a calculator out. So I hope you're okay with that. Okay. That should be obvious enough that this is a weirdo. Okay. It's pretty straightforward. You're like, yeah, but how weird is it? Oh, we'll find out in a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. Okay. So the 50th percentile would be 0.5 times 13 is 6.5, which we would round up to the 7th term. Cool. 1, 2, 3, 4, 5, 6, 7. This guy here is my median. Nice. The 25th percentile should be 3 1/4, which will round up to the 4th term. 1, 2, 3, 4. All right, and by symmetry, 1, 2, 3, 4, this guy here should be my 75th percentile. Okay, and just use symmetry. It's a wonderful thing. So I'm going to count by, I think 25. No, I'm going to count by 50s. 0, 50, 100, 150, 200, 250. Okay. And so 50 is my median. Well, that's right here. Cool. 20, my 25th percentile. 70 is my 75th percentile. There's my box. Right? So 1.5 times the width of the box. And the 1.5 is always there in like a 400 level math class. You kind of talk about why that is. But for right now, you just take it and go, okay, good. I'm happily ignorant of it. 70 minus 20. So 1.5 times 50 is 75. So 75 is how far out I would have to go to be considered weird. Well, remember, this is the number 20 here. If I go back 75, that puts me in Negativesville. We don't have any negative numbers. So we're just going to connect down to 10. That's our lowest value. On the upper end of things, we're going to start here at 70, and we're going to add 75 to it. That puts us here at 145. Okay, that's where the freaks begin. Do we have any numbers that are bigger than 1 what did I say, 145. Yeah, we do. So we're going to come over here to where he is, 250, and we're just going to make a dot. But we're not going to connect to him. We're going to connect to the next number back that is not an outlier. Okay. This is the way we'll do it with outliers. This thing right here means this is an outlier. We don't connect to him. Okay. And so we'll not connect with them. That's how we'll demonstrate that. Yes, there can be more than one outlier for certain. Yeah, there could be a couple of them up there. If there was a 225 in this graph, he would also probably would have ended up being an outlier. I mean, I say probably because we'd have to go back and redo where our median and our means and all that stuff is, right? Where our medians and our 75th and 25th percentiles are. And that may make our box wider. If it makes our box wider and we start from a higher place, the 225 may or may not be a freak, but probably would have been. And if there are two, we would simply just put two dots, okay? This is just a way to show that, yep, for sure, this guy is an outlier. Now, what did that mean? It is, like for instance, when you tested Rogaine obviously works, or they wouldn't sell it, I guess. So here, these people grew some hair, quite a bit of hair, good amounts of hair, and this guy turned into, you know, so a woolly mammoth or something, okay? That's probably not optimal. And when it comes to like drug tests, look, we only killed one person out of every 1,000. Yeah, that's a lawsuit. So you gotta be careful, right? So sometimes outliers are, like some kid will come through and they'll write, and this always happened in my stats class, they'd write some data point down, like, you know, like how tall are they or something. I'm like, seriously? You're 79, you're like 80 inches tall or something like that? And I'm like, or some ridiculous number, and I'm like, really? And then it's like, oh, I can't read a tape measure. Yeah, okay. So sometimes it's operator error. Sometimes there's things you can figure out why there is. Other times it's just because, you know, you've got some freak. And if it's a freakishly big tomato plant that puts out like thousands of pounds of tomatoes, you thank God that you have a tomato plant that does that this year. That's awesome. If it's, oops, we accidentally killed some people in our guy in our study or something, that's not optimal. And I don't discount that. Okay, so outliers, important to understand that what they are. Doesn't mean we can just discount them or throw them out. Notice that if this guy was not part of our study, if we decided that this is it was operator error, we remeasured or something and got rid of it. If you look down here, this is pretty symmetric. If you include the outlier, holy cow, it is big time skewed to the right because of this one freakish point over here on the side. Okay. So that's kind of why I like to teach box plots. They're very straightforward. There is a video for them if you need to see more about them too, but I like to talk about why we do them. And the last thing before we go today is, what if I wanted to see where I fall, or I want to see, here's a data set, and I kind of want to, I'll just use me personally. I want to see where I fall on this data set. What percentile rank am I? Or yeah, that's what I want to say. Or this guy right here, let's say this guy here is me, okay? What percentile am I? Is a particular value. Okay, so look, for instance, on this 90 guy right here, I want to know what percentile is he. Okay, so the way to do that is this: you count the number of terms less than the value, and you're always going to add 0.5 to that for reasons that are beyond the scope of this class. So if I do this, here's 90 right here, and I'm just going to make this, I'm going to make this 95 so it's not confusing. Okay, we'll talk, don't worry about that. I will never ask you for that. Now, 90, either of the 90s will come out exactly the same, but just it's for the purposes of just visualizing what I want. Let's look at just this 91 here. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers less than him. And again, we'll always add 0.5 to that, so 8.5. And then we're going to divide by the number of terms. Total number of terms. All right, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. And then we'll multiply that by 100%. Okay, 8.5 divided by 11 is that number right there is roughly the 77th percentile. Okay. If you were to ask that question about 40, there are 1, 2, 3, 4 numbers less than him, plus a half, divide by 11 times 100. He would be basically the 41st percentile. Okay, and that's how the game is played. And so you'll be given a set of data, and you know which this number here, whoever is the whatever percentile. Now, something to note about this formula. This is important. If you were 10 down here on the bottom, Jay, no one's less than me. 0 people are less than me. That's right. 0 plus 0.5 is no longer 0. Are you with me? Yeah, it's bad. You didn't do very good, or whatever. If it was like a test or something, you didn't do very good. That's true. But notice what you're not. You're not the 0th percentile. You're the 4.5 percentile. Okay. There is no such thing as the 0th percentile. Also, there's no such thing as a 100th percentile, because even the last guy up there, 10, or the upper one, the last one on the list, there's 10 numbers less than him. 10 numbers plus a half divided by 11 is, well, I'll tell you what, it's not 100%. And so there's never such a thing as a 100th percentile. There's 99 percentile and things like that and whatnot. And there's no such thing as the 0th percentile. And it comes from that formula. Okay, mathematically, it comes from that formula. From the standpoint of, if there was a 0th percentile, you are, if this was in height, you are literally the shortest person who ever lived, which there is no such critter. I mean, that doesn't happen. If you were the 100th percentile, you are the tallest person who ever lived, period. And that's it. And so there is no such thing as those two values, because there can always be, at some point, more to the value. Okay. So that's the game. Again, there's some follow-up videos on that, on the homework and stuff. But again, the idea is, where do I fall relative to the population? I guess there's one more thing I want to say, and it's just like a jiffy, so I'm going to say it anyways. A few years ago, it was big news to talk about what percentile are you in, especially to bag on the rich people and stuff. And there's a guy at my work who is always saying this sort of thing. And yet I know, because it's public knowledge what we make. At the time, I remember this because it was like 2 years ago. We were making $80,000 at the top of the pay scale, and at the high school. And his wife is a principal in another district, and so she easily makes 6 figures. So one day he was blathering about that. I'm like, dude, knock it off. You are in the top 90th. You are in the top 10 percentile. He's like, no way, Jay. I'm like, Keith, dude, you are. I said, you take what you make and what your wife makes. And I said, let's look at this for a minute and let's talk about this. And so $190,000. He's like, yeah, but we're not rich and whatever. I'm like, okay, pal. So I went to, I took him on this website, and you can go to, there's zillions of them out there. But what percentile household income am I? There's a zillion of them. Pick the one that makes you the happiest. You can go money, you can go, they all have them. Doesn't matter which one you choose, because they all basically the same. The only difference is kind of how they're looked and set up a little bit. So here they are. If you drag this little slider doodad over here, by the way, if you are making as a household income $52,000, you're in the bottom 48%. Okay. If you drag this over a little ways, you will see that at right there, 55,000 is the median. That's household income in the United States. Okay. Now, if you drag it over, right over here, $190,000, which I think is probably conservative, because I'm sure she probably makes more than 110. I said, dude, you are in the top 7 percentile of incomes, of family household incomes in the United States. He's like, but there's no way. There's the millionaires and the billionaires. I'm like, I said, there's not that many of them. He's like, there's a lot of them. I'm like, percentage-wise, there's not. Okay, think about how many households there are in the United States. There's a lot of them, like millions and millions of them. And so even if you had thousands of millionaires and billionaires to make more than you, right? percentage-wise, there's going to be a lot more percentage below you. In this case, if you see this, he's in the top 7%. That means, is another way of saying that you're in the 93rd percentile. Okay, I mean the family income. And so you can scroll that baby across there and see where you land. And we had some very interesting conversations. And he, of course, then he went off on about, so like back when we talked about houses and stuff, and talked about what do you want to buy and how in debt you want to be and that sort of thing. And so I happen to know, you know, he spends water like it's spends money like it's water. And so we had a conversation about it and stuff. And I'm not lecturing. I'm just saying, dude, I mean, just because you spend money doesn't mean you're poor, right? And so it was very interesting to note. Notice that if you drag it all the way over here to 450, that means you're in the top 1%. $450,000, which is plenty of money, is not millionaires. Okay, and so only 1% of the top of the household income make more than that. Okay, and so it's kind of a crazy thing to think about. The reason that people don't think about that way is they don't think in terms of how many millions of household incomes that you're dividing by. Okay, that is a huge number. And so even though there might be several 100,000 or several like 50, 70, 80,000 millionaires or whatever, that's great. But divided by a couple 100 million households or whatever it is, percentage wise is very, very small. Okay, so just kind of keep that in mind as you go along. Statistics are a cool thing, I think. Notice how it bends up like this. The fact that it bends up like this means that the percent wasn't growing very fast initially. And why was that? Because there's a lot of us over here, right? It's just there's a lot of us over here on this low end of things, and it's building and building and building. And we've got most of us. And then at the last second, it just shoots up. That's because there's just a few people up there that account for all of that extra amount of wealth, okay, and income, whatever, and that's good for them. But there's only a few of them up there, and so something to kind of think about. So this is stuff that's been in the news the last, I don't know how many years now and stuff, and people don't have a really good grasp on that. You know, the ones we did in class today, there's about 10 or 12 data points, all right? Well, that's great, 10 or 12 data points. Well, you know, you saw how to make those graphs, you saw how to make those percentiles, but if you had the data of every income, every household income in the US, and you listed them out in order, then you could go along. That's where the 75th percentile is, and that's where this percentile is, and this is the 90th percentile, exactly like we did in that last problem right there. So the 90 was the whatever percentile. That's exactly how those data, they come about, those data points. Okay, and so just something to think about. Just be aware of that. A lot of people just really don't get percentages and averages very well, and I think that's kind of sad. It's something I'd like to change if I had a way to change it, wave my magic wand. So I do my little bit in my class and hope for the best. Test is next week. It'll come live at 8 o'clock in the morning. You'll have until 11 to do it, and then you'll have another half an hour to get it uploaded. Okay. So I don't really want to hear a ton of well, I couldn't upload it and this and that and whatever, because I gave you half an hour. So in class, you'd have just under 3 hours to do it. I will give you a full 3 hours to work on it. Okay. And I will be near my computer for if you have any questions, you can email me. I will not be spying on you or whatever. I don't care about that. If you don't know what you're doing, you could have all day in essence to work on it. You're not going to do a good job on it. So you have 3 hours to get it done. There's a review posted that is almost very similar. So it'd be very similar problems to the review. I will say that on the review, on the, I think there's a mistake. I think I'll try to get that remedy today. I think I sent it out last month. I think I sent it out last time and I forgot to fix it. On the credit card problem, I think the average daily balance is wrong on that. So I think that's the only mistake that I made on my key for it. Everything else will be very similar. Do it on paper. Show the work that you do. You're going to scan me the paper, and then scan me a picture of the paper, and then you're also going to be using Excel. In Excel, you're going to be making a couple of graphs, and you're going to be do all of your work. So like calculating payments, calculating how much is saved, all that. You're going to do that in Excel. Make sure they're labeled what sheet they are, what problem is which, so that when I'm grading your test and the answer is supposed to be $1,000 a month and you have $750 or something, I can go online and see. I can go on your Excel sheet and see where you made a mistake and give you partial credit if it's warranted. Same thing with the credit card. Do the credit card worksheet on there, or do the credit card problem on there, and then your average daily balance, let's say, is off by a few bucks. I can go on there and give you partial credit for it because you did the right idea. Okay. That's the game this week. That's for next week, next Saturday morning. And again, 3 hours to do it is a little more than you have in class, plus another half an hour to get it uploaded. Should be plenty. Should be plenty. So yeah, just let me know. Questions, comments? No, that was quick. All right. Anyway, if you've done the homework and you've done the quizzes and you've done well on them and the worksheets and you've done well on those, you will find the test to be pretty straightforward. Okay. And again, it'll be very similar to that review. First of all, it's the same stuff. So it's kind of hard to come up with like, oh my God, that's new. No, dude, you're buying a house. I'm going to ask you about payment. I'm going to ask you the total cost and how much interest you paid. How much money you'd save if you refinanced. I mean, there's only so many questions I can ask. You're like, so, oh, it's the same basic thing. Yeah, of course, it's always the same basic thing. So don't get all, is Jay going to pull something weird out of his hat? No, they're going to look very similar to that. Okay. All right. That's it, I guess. All right. Have a good weekend and take care.